Okay, so just now we looked at ion extraction. Okay, and then as I was telling you, all metals they exist as the metal ores because they are reactive, except like your silver and gold. Okay, so apart from ion extraction, where my main reducing agent is carbon monoxide, right? I can actually also extract these other metals, right? Example, my potassium, sodium, calcium, magnesium oxide, or the zinc lead oxide. Okay, I can extract or I can reduce them by carbon and hydrogen. And that's why in my metal reactivity series, I actually have carbon, which is your concrete zoo, okay, and hydrogen, which is however. Okay, so let's look at this. How do we reduce the metal ores by using carbon and hydrogen? Okay, metals that are higher and more reactive than carbon in the reactivity series, they cannot be reduced by carbon. Okay, so these metals, especially your group 1 and group 2 up to group 3, your aluminium, right? My 1, 2, 3, they are more reactive and higher in the reactivity series. So I cannot reduce or I cannot extract them using carbon and hydrogen. So I must use or I must pass electricity through it, all right, to extract pure potassium, pure sodium, pure calcium, pure magnesium, pure aluminum. Okay, electrolysis is a chapter by itself before organic chem, and we will look at it a lot more in detail when we look at that chapter. Okay, then over here I have my transition metals. So transition metals are below carbon, so they are lower and less reactive than carbon in the reactivity series. So I can use my carbon to extract or to reduce to form the pure metal. So example, if I have zinc oxide, okay, plus carbon, this one will give me Zn pure metal plus CO2, and then we balance up your equation, okay? If, for example, I have CaO plus C, right, because my calcium is higher, my calcium is higher than carbon in the reactivity series, there is no reaction. I cannot use carbon to extract calcium from calcium oxide. Okay, then I can also use hydrogen to do the reduction, right? Hydrogen, so based on your reactivity series, if I decide to use hydrogen, what we have to remember is my hydrogen will move up 2 steps, okay? So it moves up 2 steps, right? This hydrogen, most of the time we are referring to the acid reaction, the metal acid reaction, okay? But if it is a reduction process or an extraction process, I have to move the hydrogen up 2 steps. So essentially now the hydrogen is below zinc. Okay, so same idea, right? If I have zinc oxide plus hydrogen, this one, because my zinc oxide or zinc is still more reactive than hydrogen and it's higher than hydrogen in the reactivity series. So I cannot use hydrogen to reduce zinc oxide to form zinc. I cannot do that. Okay, so if I have example iron oxide now, FeO, okay, so iron oxide plus hydrogen, this one, right, because iron is lower than hydrogen in the reactivity series because I have to move hydrogen up 2 steps, okay, so iron is lower, okay, iron is lower and more less reactive than hydrogen in the reactivity series. Therefore, I can use hydrogen to reduce iron oxide, to form iron. Okay, so this reaction, I will have my iron oxide plus hydrogen. It will give me Fe. Again, I'm trying to extract the pure metal plus H2O. Okay, same thing is about balancing up your equation. Okay, and then, so remember, right, the important part when I'm doing carbon and hydrogen reduction of my metal ores, right? Your hydrogen will shift to below zinc. Okay, so this one we talked about the group 1, group 2 metals. We also talk about the transition metals, and then please remember, generally my copper, silver, these are unreactive, so they are usually uncombined in natural state. Okay, for your zinc, iron, and lead, and your copper and silver oxide, right? If they exist as the oxides, right, I can also use electrolysis. But we do not do this because it is difficult to set up and it is more expensive. Okay, these two pictures shows the typical example of how I use hydrogen to reduce my metal oxide. Okay, so I blast hydrogen, set up a U tube with fused calcium chloride. This is my drying agent. Okay, and then I will just pass the pure hydrogen gas through the metal oxide and burn it. Okay, the gas that burns at the back is always my excess hydrogen. Okay, hydrogen is flammable, it is not oxygen. Okay, or alternatively, I can just heat it over a crucible. So I have the metal oxide as well as add some carbon, the coke inside, and then I will just heat it over the crucible of a ceramic dish. Okay, and then I will see like reddish brown solid in this example.